What comes to your mind when you hear Kubernetes? Well, to my mind, it was initially where to start with and how to use it. Let me give you a very brief idea and high level of Kubernetes. Then we can dive in to more into the concept of Kubernetes in coming videos. My name is Pradeep, and please join me to start learning technologies. But today, let's explore the basic architecture of Kubernetes. Let us understand Kubernetes in a basic diagram. In a very high level, Kubernetes cluster is divided into two parts: control plane or master node and worker nodes. To the left side, I have created a control plane space, and to the right side, I am creating a worker node space. So the basic architecture that I am creating will be having one control plane and three worker nodes. We can have multiple control plane as a part of high availability architecture, but here we are considering one control plane and three nodes of worker node. If I talk about the hierarchical structure of Kubernetes cluster, the topmost part is cluster, then comes the control plane and worker nodes in parallel inside it. Inside each worker node comes pod, and then inside the pod we have the container under which our application runs. If you see, the blue one is the pod under which the container is going to run, and the container is nothing but it's an application which you are going to use for your purpose. Now, talking about the container, yes, we need a container runtime engine in order to containerize each and every components of the cluster. Whatever is running inside a cluster will be in the form of software running inside a container. So a container runtime engine must be installed in control plane as well as in all worker nodes. Docker, Rocket, or any of the container runtime engine is compatible to the Kubernetes cluster. Initially, Kubernetes was dependent to Docker, but now any container runtime engine can be installed in order to containerize any software or network solution or DNS running inside cluster of Kubernetes. Okay, so as you see in all the three nodes, I have created pods just to showcase that inside a node we can create node to run our application. We will be learning more about how to create pods, how to use it, how to deploy it in our coming videos. Also, we will be seeing the replica sets, different replica sets, the count of replica sets for the pod creation in our coming videos. Now, you must be thinking that can we run two containers inside a single pod? The answer is yes, we can run two containers inside a single pod. But it's a good practice to execute your container in a single pod. There is a very good concept of networking in Kubernetes cluster as well. There is two types of networking in Kubernetes. In a very high level, if I say the networking on the level of cluster, where the IPs for nodes and control plane is assigned, and there is a networking on the level of pods. Yes, when you create pod, it is assigned with an IP address, and whatever application you are hosting inside the pod as a part of container that are accessible via those IP and the port number exposed into it. Please don't be confused. We are going to explore all these terminology and concept in detail in coming videos. For now, we will be stick to a very brief architecture of Kubernetes. Okay, after exploring some parts, some components of worker nodes, let us begin exploring control node, what it is actually and what it contains. So let us check out the different components of master node or control plane node. In control plane node, there are four major components. The first is API server, second etcd, the third is scheduler, and the fourth is controllers. API server is the main component in Kubernetes cluster, which is being used to communicate to all worker nodes. Also, it is being used to basically Kubernetes API server orchestrate all operations, and it exposes all the APIs which is being used by all externals as well as all the components within the cluster. We'll talk about it later in all upcoming videos. etcd is nothing but it's a database which stores all details about whatever is happening in worker nodes, about pods. Each and every data is being stored in etcd. etcd it stores the data in key value pair. We can set up etcd as a cluster inside control plane, or we can set up HCD in cluster outside the control plane and can communicate that HCD outside from control plane as well. Controllers, there are multiple controllers inside control plane. Different controllers have different functionalities. For example, if we want to add new node, then onboarding of the new node, the state about the node, whether it is healthy or not, periodic checks about the node, whether it is good or not, these all are controlled by controllers. So as I mentioned, there are multiple controllers for each and every functions. So these controllers are inside controller part. For example, node controllers, replication controllers, how many replicas needs to be created for each and every container, and where these replicas are running, their health states and everything is controlled by controllers. Schedulers are something that identify the right node to place your containers into. Now, based on the container resource requirement, worker node capacity, or any policies into it, the scheduler schedules the container or pod into a particular node. So inside control plane, it's API server which talks to HCD and other components like controller and scheduler, and give its response to worker node to what needs to be done, and vice versa. But how a worker node connects with a control plane, how this information is being passed to control plane. So basically, the API server is the main point of contact from the worker node side, as well as from the control plane side. It's the API server which gives request to worker node. So how does it happen? We have something called kubelet. It is nothing but it's an agent which is installed in each and every worker node. We will talk about in detail about the kubelet agent. Now, how about the interconnectivity between different worker node works? Let's say I have an application which is deployed as a pod in node 1, and I have its database which is deployed in node 2 pod. How this connectivity will work? So the answer is kubeproxy. So kubeproxy is something which is installed in each and every worker node, including control plane, and this kubeproxy provide a network communication within the cluster. This is all about the basic architecture of Kubernetes cluster. In this video, we'll talk more and deep dive into different single components of Kubernetes cluster and how it works about installation in coming videos. Stay tuned with me and learn about different Kubernetes technology. Thank you so much for watching.